Hi, welcome to another DraftScience presentation. Okay, on Doppler shift, sort of. Professor Lewin video. And I did attempt a comment exchange. I really don't like doing text comments to have interactions with people, but I guess that's what I'm stuck with for a while. So I can't get anybody to interact any other way. So anyway, he made a video. Apparently he likes doing math stumpers or something. This is apparently what nerds like to do with their free time, is math problems. And I'm not totally opposed. I like concept problems more than let's just do a bunch of derivations. But anyway, so in this video he makes this kind of explicit statement that the speed of sound, particularly, we're not talking about Doppler shift in other forms of radiation, just in light or anything else. We're just talking about shift in sound, and that there's a circumstance in sound where it matters whether the transmitter is moving away from you or the receiver is moving away. That somehow the shift is different if the receiver is moving versus the transmitter moving away. He said it's unintuitive. It only holds for sound, and I personally don't think that's true because I think all shift is the same. So receiver shifts, the shift caused by a receiver moving away or moving towards, is exactly the same as the shift caused by the source moving towards or away. It's always the same. It's a conservation thing in a sense. The receiver, if they're moving together, they perfectly undo the shift they create. So they're both moving this way. The transmitter shift is completely undone by the receiver shift. So that would be the principle involved. So I'll attempt to play some of this and just point out that he basically says it twice in this video. He emphasizes that sound isn't the same. The receiver and transmitter created, there's a different variable involved, and the amount is rather significant, like 30% difference kind of thing.
Hello. Okay, I'm going to work with you on the problem of the Doppler shift. Let's first deal with the Doppler shift of sound. The speed of sound I call V of S.
Could speed it up here.
Here's a transmitter which generates in its own frame of reference sound with a frequency f0. Here is the receiver, which moves in this direction with speed v receiver, and it records that this f0 generated in this frame of reference is recorded in the receiving frame as f prime. How do we derive that? I suggest you look it up on the web. They probably lead you step by step through the derivation. Well, it's not so intuitive.
So, not so intuitive. This is a line he uses a lot. And often he's correct, I would say, in saying some things happen that are not what you would think, what you would expect. Optical illusions, for example, or something.
That whether the transmitter moves away from the receiver has a different effect than whether the receiver moves away from the transmitter.
So you heard that. When the transmitter moves away from the receiver is a different effect than when the receiver moves away from the transmitter. And he's saying it in the sense of different effect in that it is a real effect, in that the numbers change rather significantly, in my opinion. Alright, so I'll move ahead to around 10 minutes because he says pretty much the same thing a second time. That it's unintuitive and it only holds for sound. Play.
Let's say 1/10 of the speed of sound. You get a different Doppler shift than if the receiver moves with 1/10 the speed of sound. And you've seen that as a result of my equation. So these are the answers to 1 and 2.
Okay, so you heard that. Okay. we'll play that part again at regular speed.
With a certain speed. That is not intuitive, but that is the case. So the problem is not symmetric. If the transmitter moves with a speed of, let's say, 1/10 of the speed of sound, you get a different Doppler shift than if the receiver moves with 1/10 the speed of sound.
Alright, so you can't make it more clear what he's saying. So I'm just saying, and somehow we can't, I can't communicate with him on that premise, is what I'll illustrate in the comment section, because I'm arguing that as a statement of fact, and I'm trying to understand how we know that to be a fact. Okay, so I state, let's just make sure this is in the frame. No. So yeah, let's fix that somehow. That ain't gonna fix it. So let's try smaller text. And maybe that's enough. Let's see if it fits now. Oh, close enough. It'll have to do, as they say. Alright, if the receiver shift is different, this is my comment to him. If the receiver shift is different than the transmitter shift, what about the case of two people opposite each other talking on an open air moving train car? It could be argued that the shift imposed on one speaker's sound is exactly undone by the other person's. So whether I'm talking into the wind, so to speak, at somebody, or I'm the opposite side and I'm talking with the wind, whatever effect of shift that takes place in the conversation is going to be exactly undone by the fact that the receiver is moving in the opposite direction. And you could think of it in terms of just taking the car and separating them. So he's on one car and I'm on another car, and we're moving the same. You know, however you want to do it, to disconnect this idea that there's some frame thing that matters here. There's no frame thing that matters. It's just the fact that if the shift is unavoidable in both cases and it's exactly symmetrical. Alright, it could, okay, so I did that part. It could be argued that the shift imposed on one speaker's sound is exactly undone by the other person's receiving the sound. Can you cite experimental evidence regarding the difference between transmitter shift and receiver shift? So I'm just trying to get to how we know this is true. Okay, and so his first response was, use the Doppler shift equation that is in my solutions. So I clearly asked for experimental evidence. I mean, you can't miss it. Can you cite experimental evidence? And he cites an equation. So that's not really an answer. Alright, so, okay, fine. He's the professor. He doesn't want to, you know, blah, 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 give you the simple answer. Anyway, so then I say, not trying to be argumentative, but this isn't much of an answer. I am not looking for a theoretical math proof. I am looking for a physical proof, experiment, of receiver shift being different than transmitter shift. Okay, and then he says, use Google. Oh, Jesus. There are countless demonstrations that show this. In bold. Go try to Google that specific subject and see. Good luck. Okay, is all I'm going to say. Listen to my solution. So again, go back to the math. You know, just as context, when Professor Lewin did his lectures, unlike the other physics professors, he did a lot of experiments. Most physics professors think physics should just be technical and math, and they shouldn't have to demonstrate anything, that you just take it on their advice that this is what the experiment showed and no point in doing it. But Professor Lewin did the experiments, which was really nice. And so I'm basically asking for the experiment. Alright, so it says, listen to my solution. If R moves away from T with the speed of sound, then the sound will never reach R. Well, so what? You know, in my circumstance, the same is true. If the two are symmetrical, if you move the speed of sound, you're still not going to be able to hear the other person across the train. So, you know, it doesn't change the fact that sound can't you can't have a conversation if you're moving faster than the speed of sound on a train, so to speak. I mean, open air. So more than 700 miles an hour, the conversation can't take place because your voice can never overcome the fact that you're moving faster than the waves of sound can get to the person. So they're always going away too fast, put it that way. They're moving too fast away for your sound to ever get to them. Alright, if T moves to R with the speed of sound R, this almost looks like it was edited. I don't see, I guess they might not tell you when a comment's been edited. But anyway, when T moves to R with the speed of sound, R will experience the sound booms as wavelength of sound that reaches R is 0. So again, he's using these two examples of the fact that you can't, sound creates sonic booms, and if your distance is going faster than the speed of sound, like with light, if you went faster than the speed of light, then light you can never see it. Well, that doesn't change. That doesn't provide a reason, a logical reason, or a physical explanation of why it's still not symmetrical. Those the two extreme circumstances aren't made more illustrative by making the two kinds of sound, the two kinds of shift, non-symmetrical. Symmetry has nothing to do with the fact that, yes, if you move faster than the speed of sound, you can't hear what somebody else says. Alright. Variable Doppler shift. So he's got two replies here now, and there weren't two replies before. So this reply was somehow, I don't know how it got in there, but I see it now. It wasn't there before. Variable Doppler shift measurements of radio signals, right, of Sputnik, so this one I remember, as it goes around the Earth, made it possible to determine its speed of orbit, and from that follows immediately its distance to the center of the Earth. Doppler shift of radar is used by the police to measure the speed of a car. So again, these are all electromagnetic radiation. This isn't sound. Sputnik was a sound wave carried on radio, so it doesn't count as sound. And his theory was specific to sound only. He made it clear this is only affects sound, audio. It doesn't affect EMF or any other light kind of transmissions. So I said, you specifically said in your video that this unintuitive fact of different shift towards and away only affects signals moving the speed of sound. Sputnik produced radio signals, not sound. As for Googling for a physical evidence source, I found no sound-specific reference. So it's very hard to separate on the subject of Doppler shift sound references and other energy source references, and specific on the idea of this idea that transmitters moving versus receivers moving creates a different kind of shift. Alright, so he says, he quotes me, you specifically said in your video that this unintuitive fact of different shift towards and away only affects signals moving the speed of sound. And he says, I did not say that. So again, I think he says it explicitly right at the part I stopped the video. So let's play this part.
And you've seen that as a result of my equation. So these are the answers to 1 and 2. Now, special relativity. I am here.
Yeah, okay.
And
I thought he did say it there. I think he did, but let's go back a little.
50 Hertz. Remember what I said earlier, that it makes a difference whether the transmitter moves with a certain speed or whether the receiver moves with a certain speed. That is not intuitive, but that is the case. So the problem is not symmetric. If the transmitter moves with a speed of, let's say, 1/10 of the speed of sound, you get a different Doppler shift than if the receiver moves with 1/10 the speed of sound. And you've seen that as a result of my equation. So these are the.
He also reiterates you know, that this only holds for sound. So I'm telling you, he does say that twice in the video. It's only the case with sound. It's not the case with general relativity or anything else. So I just want to make sure that point was emphasized. Okay. So the speed of sound, Sputnik produced radio, I found no sound reference. Okay, so then he says, I did not say that. Approaching increases the frequency, receding decreases it. Yes, and you're saying it's non-symmetrical. The amount of increase is not symmetrical to the decrease, depending on whether it's a transmitter increasing or the receiver is decreasing. That is true for both sound and EM radiation. So again, how can you? So he says it's both sound and I don't understand. So he's implying symmetry when he just said it's not symmetrical and it's unintuitive. Now he's saying basically, yeah, they're all the same in a sense. In the case of sound, it matters. So he just reiterates it. In the case of sound, it matters whether the receiver or the transmitter moves. So he says approaching increases frequency, receding decreases it. But if you wouldn't say that if the decrease is smaller than the increase. You'd only say it like that if they were the same. Alright, that is not the case for EM. Alright, so read more. Radiation. The change in Doppler shift of Sputnik. So he brings up Sputnik, right? I didn't bring up Sputnik. I was trying to understand the sound difference. And so again, now we're going to argue more about Sputnik. I'm like, this subject isn't Sputnik. It's due to its rotation around the Earth. The Doppler shift only measured the radial velocity. Use Google. Why would I use Google? I'm trying to find a sound experiment, not a radio experiment. So again, that changes for any given radio receiver. So again, he's talking about radio receivers when he explicitly said this doesn't hold for radio. That is not the case for EM, radiation. He just says it right there. And now he's giving me the case of radio waves. I just don't understand how radio waves are the subject when I'm clearly trying to talk about the evidence of sound waves where the transmitter creates a different Doppler shift than the receiver. That change for any given radio receiver when Sputnik moves in the sky. So again, just what? So my last comment, for which he didn't reply, you said that there is a different effect when the transmitter moves away from the receiver than the effect of the receiver moves away from the transmitter. It's so intuitive. I should have said it's not so intuitive. Right, that's what I quoted. And not the case in GR or EMF. And so I'm just quoting what exactly he said. I played the video again. I quote what he says. And so I state kind of plainly, I'm trying to understand the physical reason why moving the receiver is different than moving the transmitter. And that's when he stopped responding. So I'm just saying it's very frustrating. Seems like I was inquiring about a very simple thing. He claims there's in sound, Doppler shift is not symmetrical. He stated it. And I want to understand why it's not symmetrical, the cause of this asymmetry. And apparently I will be provided no information beyond the fact that he says his derivation proves it. And evidence is not relevant. Apparently. So anyway. Most unsatisfactory. So I'm hoping he gets to a interference math problem so I can bring up the radar experiment where I think it's, the radio signal is just being jammed. The two signals can't be received by the receiver in the radar experiment, and that's why it looks like an interference pattern when no, it's just a jam signal, a not jam signal, a jam signal, a not jam signal. So anyway, yeah, that's all I can say. So it's a little disappointing, but just, you know, life on Earth is full of that and such.